Have you ever noticed that when you're using an AI chatbot, those first few replies are just lightning fast? But then, if you keep that exact same conversation going for, say, an hour, the responses just start to crawl. It's such a common frustration, right? You're just sitting there, staring at the screen, watching that cursor blink as the AI seemingly struggles to get the next word out. Well, welcome to today's Explainer. We're going to look under the hood of these massive language models to uncover the completely fascinating, mechanical reason behind this everyday annoyance. Let's just dive right into it.
So this is the core question we are tackling today. Why does a wildly powerful AI running on literally massive supercomputers get sluggish the longer you talk to it? It's kind of a brilliant technical mystery when you think about it. And to solve it, we can't just look at the software layer. We really have to understand the fundamental architecture of how modern AI processes human language. And it all starts with a rather surprising limitation in how these models actually read.
Section 1. The Goldfish mechanism. Let's talk about autoregressive models and going one token at a time.
Okay, so here is how an autoregressive model actually works. Step 1, the AI reads your input. Step 2, it guesses the single next word, just one. But here is the absolute kicker. In step 3, to generate the word after that, the AI doesn't just naturally remember what it just did. Nope. It naturally wants to start completely over, rereading the entire newly formed sequence from scratch just to guess one more word. It is a staggering amount of redundant math.
Think about it like this, because I love this analogy. It's like reading a book from page 1. Every single time a single new word is added to the page. If the book is 3 words long, okay, no big deal. But imagine the book is 3,000 words long, and you have to read all 3,000 words just to write the 3,001st word. That is a total nightmare. In computer science, we call this a quadratic compute redundancy. Basically, the longer the sequence gets, the exponentially harder the math becomes.
Section 2. The KV cache shortcut. Let's fix that redundancy.
Look, if the AI actually worked like that book analogy for every single user, data centers would literally melt down. So engineers built a really clever shortcut, and it's called the KV cache. Deep inside the AI's architecture, it uses things called keys and values to understand context. The KV cache simply takes the heavy mathematical computations for the words it has already processed and saves them in a vault. Because, hey, passwords don't change. So the AI doesn't have to rethink them every single time.
So, what's crucial here is that this splits the AI's job into 2 distinct phases. First, you have the pre-fill phase. This is when you hit send on a massive prompt. The model processes that initial prompt all at once, running all of its processors at absolute maximum capacity. But then comes the decode phase. This is where the AI actually generates your output, one token at a time. Instead of recalculating everything from scratch, it just uses the KV cache for the old words and only does the heavy math for the brand new token.
So you can see why this is a total game changer. The KV cache essentially turns a massive full sequence recomputation into a really lightweight incremental update. It completely avoids recomputing the whole chat. It only calculates the complex math for the new word, and then it just simply appends that new data to the running cache. It's an incredibly elegant engineering shortcut that saves vast amounts of computing power. So problem solved, right? Well, actually no, not quite.
Section 3. The growing memory burden. Let's look at the actual cost of KV caching.
You see, every shortcut in computer science comes with a cost. There's no free lunch. And the catch to this brilliant KV cache shortcut is the physical toll it takes on the hardware's memory. I want you to think of the KV cache as a heavy backpack that the AI has to wear. For every single new word generated, a new row of data gets shoved into that backpack. As your chat grows, the heavy backpack of the KV cache grows right along with it. There is a direct, linear relationship between the length of your conversation and the sheer size of the data the AI has to actively drag around.
Let's put some real numbers to this to put it into perspective. 2 gigabytes. According to data from NVIDIA, if you take a standard, relatively small, 7 billion parameter language model, and you give it a sequence of about 4,000 tokens, which honestly is just a moderate length document, the size of the KV cache just to store those keys and values is roughly 2 gigabytes of memory. Let that sink in. That is 2 gigabytes of physical hardware memory reserved for a single user's single conversation.
And right there, that brings us to the root of the lag you're experiencing. The KV cache size scales linearly with sequence length. But here is the real bottleneck.
All of this cache data has to be physically moved from the hardware's memory into the actual processing chips, the GPUs, just to generate the next word. Moving gigabytes of data back and forth physically takes time. It's not that the AI brain is suddenly thinking slowly, it's that grabbing the files from that massive backpack takes too long. This memory-bound transfer is exactly where your lag comes from.
Section 4. A real-world long thread. Let's look at the real-world latency impact.
Let's connect these under-the-hood mechanics straight back to your actual screen and your daily experience. Imagine you're asking a chatbot to plan a big trip for you. At the start of the chat, you type, "Hey, plan my vacation." The context is tiny. The KV cache is super lightweight, the prefill is instant, and the decode phase spits out words rapidly. But fast forward an hour. You're at the end of the chat. You're refining the day 5 itinerary, and your conversation history is now 3,000 words long. Now, before the AI can output the very next word of your itinerary, it has to load that massive KV cache containing the entire history of the chat into the GPU. That massive memory drag is exactly why the text generation suddenly feels like it's just lumbering and lagging along.
By the way, this heavy backpack problem perfectly explains another major feature of AI you've probably run into, the context window. You've probably hit a limit where an AI says it can't remember any further back, or it straight up refuses to read a massive document. The context window is the hard cap on how many tokens an AI can process, and this cap exists precisely to prevent the GPU's memory from completely overflowing due to the size of the KV cache. If the context window is infinite, the KV cache would just grow until the server literally ran out of physical memory and crashed.
Section 5. The ultimate trade-off, memory versus speed.
As we wrap up this explainer, we arrive at the fundamental law of computing that governs every single modern language model you interact with today. It is a strict, undeniable balancing act. On one hand, you have the desire to remember everything. Having a massive context window allows for incredibly deep, rich conversations, but it requires a massive KV cache, which inevitably results in slow, memory-bound latency. On the other hand, you have the desire to stay fast. To keep generation speeds lightning fast, you have to keep the memory footprint small, which fundamentally requires limiting the context window and forcing the model to forget past context. Now, engineers are constantly developing brilliant workarounds to manage this memory better. But the core physical limits of the hardware, they remain.
So the next time your chatbot starts to slow down during a long, deep conversation, you'll know exactly why. It's dragging the heavy backpack of your entire chat history, its KV cache, in and out of its processors just to find the perfect next word for you. It leaves us with a pretty fascinating question regarding the tools we rely on every single day. If you had to choose, would you rather your AI remember absolutely everything you've ever said to it or answer you instantly? Think about it. Thanks for joining me for this explainer, and keep learning.
If you enjoyed this video, please like, comment, and subscribe for more AI and technology content. Thanks for watching.